Hello students, in this video we are going to finish up the lab number 4, the McDonald's French Fries lab. We're going to look at the hypotheses test process, which is listed under your report tasks number 5, inferential statistics steps 4 and steps 5. Steps 4 says test to determine if the mean length of French fries is greater than 8 centimeters. This is based on the original or the claim at the beginning of the lab assignment that states that McDonald's has claimed through its advertising and marketing departments that the average length of its French fry is greater than 8 centimeters. And then the second part states that more than 50% of its French fries are greater than that length. We are in the lab, we tested those claims. We first developed confidence intervals for the average length of the French fries and for the proportion of French fries greater than 8 centimeters. What we're going to do now is look at how to carry on the hypotheses test. So the first thing we want to do is list out the hypotheses. The null hypotheses would be that McDonald's claims that their average French fry length is at least 8 centimeters in length. The alternate hypotheses would state that the average is less than 8 centimeters in length. We know from looking at the question, it says here keyword greater than, as well as in the task it says test to determine if the French fry is greater than 8 centimeters. That is our key word, which tells us that it is a one-tailed test. So we know it's a one-tailed test, and we are testing at, the question states, test at the 5% level of significance. So alpha is 0.05. So we take our sample. We found that the sample data, which I have right here, these are the lengths of the French fries that I counted. I counted 113 of them. I got an average length of 6.8. That value I need, and the standard deviation is 2.44, and I have 113 French fries. I'll need this value later on. We'll just change it to no decimal places. 32% of the French fries are greater than 8 centimeters. So let's take a look at what we have. We know that, let's list this in another color. We know that the average French fry is 6.8 centimeters. Standard deviation of those French fries is 2.44, and we have 113 French fries. Hypothesis testing, the process is to compare a test statistic with that of a critical value or a threshold value. Because alpha is 5%, and because we do not know the population standard deviation, we're going to have to use a t-value. And a t-value is based on alpha as well as the degrees of freedom. Degrees of freedom being 1 minus, or n minus 1. I'll just write that down here. N minus 1. In order to find that t-value with an alpha value of 0.05, and because it is a one-tailed test, we don't divide alpha by 2. We only divide alpha by 2 for confidence intervals and for two-tailed hypotheses tests. So we should be able to find the appropriate t alpha value. Let's just denote that t alpha by looking at the charts we have in the course package. But because our degrees of freedom is so large based on our sample size, where we have to go find that t value, the critical value t, is on this Excel sheet that I have placed on Blackboard for you, as well as under your course content. It's called Finding T and Z. This is what we use in the first part of the lab report in order to find the correct t-value for confidence intervals. Now to find the t-value for hypothesis testing. We're testing at 5%. Our sample size is 113 and it is a one-tail test. So our appropriate t-value is 1.659. Let's write that in there, and it is negative 1.659 because we are working on the lower end of the distribution. If we were to draw this out like this, McDonald's states that the French fries are 8 centimeters. They're actually stating that they're at least 8 centimeters. So we are going to be testing to see if it is less than 8. If the average French fry in our sample turned out to be greater than 8, there's no issue with McDonald's claim. However, we're going to be testing that it is less than 8. So we find a critical t-value, which we're going to put right there, and it's on the lower end of the distribution. So that's why this value is negative. This becomes our threshold value, the value at which we would state that if our test statistic is less than that value, is more extreme than that value, we're going to reject McDonald's claims. We're going to reject the claim of the null hypotheses. So the next thing we have to do is calculate a t-value. So remember, in hypothesis testing, we find a value. We find the critical value or the threshold value, and then we calculate the test statistic, the t-value from the sample data, and that is by using this formula there. Oops, that should be the sample size. So let's plug in our values. We got 6.8 minus 8 divided by our standard deviation from our sample divided by the square root of 113. We get a value of negative 5.23. That value would be placed way out here on this on that normal distribution. If we were to continue this distribution, we would have it kind of like that. So we know that it's more extreme than our critical value. Our critical value tells us at what point we would reject the null hypotheses or not reject it. So anything over here from our critical value is basically okay. Anything this side of that critical value is basically not good. Let's just put this down here for ease. It's not okay. Basically anything past that critical point. So because of our calculations, because of our sample data, we're left with stating that our decision would be to reject the null hypotheses, and that's what we should state. We are rejecting it because negative 5.23, this value here, is more extreme than the critical value. The basic decision rule is to reject the null hypotheses if your test statistic is greater than your critical value. In order to use the negatives in there, I would make those values absolute when comparing the two t-values. So if the test statistic is greater in absolute size than the critical value, we go ahead and reject the null hypotheses, which basically means that we have enough evidence to state that the claim is not correct. The next thing we want to do is do the hypothesis test for the proportion of French fries. The statement is, or the claim is, that the proportion of French fries is more than 50%. It's actually the proportion of French fries that measure more than 8 centimeters is more than 50%. So another key word right in there, more, that signifies that is a one-tailed test. So let's erase this and start all over here. Let's start with our null hypotheses. It's a proportion. The null hypothesis is that the proportion of French fries that measure 8 centimeters or more is at least 50%, is greater than or equal to 0.5. The alternate hypothesis will be written like that, is the proportion, got those backwards. 1 second here. Let's start that all over. Don't do this on the test. Proportion of French fries is greater than or equal to 0.5. The alternate hypothesis is that it is less than 0.5. And once again, we are testing at the 5% level of significance, 0.05. Our sample data back in our Excel sheet showed that the proportion of French fries greater than 8 centimeters is 32%. So our sample data is this, and we have 113 French fries. Because it's a proportion, well, the process is the same. Proportion, we can use a Z value for a critical value. In order to find that Z value, we can go to the same finding T and Z chart. 5% level of significance, 113 French fries, one-tailed test. There is our Z value, 1.64. And it would be negative because we are on the lower end of the distribution. We are concerned that the French fries are less than 50%. The test statistic for the proportion hypothesis test is the sample proportion minus population proportion divided by the square root of population proportion minus 1 minus p over n. So substituting in those numbers, we would get something that looks like this. 0.5. Important to remember that in hypothesis tests for proportions, we use this population proportion value as the standard error, divided by 113. So this gives us a value of approximately negative 3.83. Once again, because that value, negative 3.83, is more extreme than our critical value of 1.64, we are going to reject the null hypotheses. Another way of making that decision is looking at the absolute value of the test statistic and our critical value. So if the test statistic as an absolute value, as a positive value, is greater than the critical value as a positive value, we then make the statement to reject the null hypotheses, which means this statement here is rejected, which means that the average French fry, the proportion of French fries greater than 8 centimeters is not 50% or more.